Hello friends, today we are going to learn how to configure analog input, analog output in a PLC. Okay, so let's begin. Along with analog input and analog output, we will also see how to add digital input, digital output modules and also the communication modules. So let's begin. As you all are very familiar with how to create a hardware configuration or create a very simple PLC program in a S71200 in TI Portal V13. I am not going to repeat the configuration steps of how to create a project and all that and how to add the CPU. We'll directly begin with the topic of how to add the signal modules, signal boards, communication modules, technological modules in the hardware of PLC. As you all know, this is the device view or device configuration window for TI Portal S71200 software. Now, this is a PLC. Yes, if you could see, this is the area which is being highlighted. It is available to add signal board. What do you mean by signal board? Signal board means you can add one or two AIs, one or two DIs. That means if you had 10 DIs and 10 DOs in your PLC, so this is 10 DI and 10 DOs. 14 DI and 10 DOs, as it is 1 to 1 4 CDC. So and if and also there are two AIs, but they are voltage configured. You can't configure them as current. They are by default configured as voltage. So if you require a single analog input which is using current as a module, you are not going to purchase a separate signal module. You can go with a signal board. If the same applies to analog output, if you are just getting you just have a single analog output to be configured in your device, you want to add that in your hardware, you can use a signal board. If you are short of only 2 DIs, 2 DOs, 1 DI, 1 DO and similar kind, so you can use this space. Now how to use this space I will show you now. So click on this, go into the catalog. Yes, it is open for you now. Go to signal boards. This is DI. DQ stands for digital output, DI stands for digital input, DI/DQ stands for digital input, digital output, analog input, analog output. So see, they are specifying only 4 DIs but 5 volt, 24 volt, 4 DOs, AIs, 1 AI of 12 bit, that is normal, 1 AI with RTD as an input, one as thermocouple as an input, then 1 AQ as 12 bit normal analog output. Then in this option you have 2 DIs and 2 DOs. Okay, 24 volt DIs, 24 volt DOs, 5 volt DI, 5 volt DOs available. Now for time being, we will use any module. I can use this one. Okay, since we are going to see this all later on. So this is 2 DI. Okay, I will just click it, open it and see there are two modules available. So whatever version of hardware you have, you can click. Okay, I will go for the recent one and see, I am just dragging and dropping. Okay, the plus sign arrives, that means it is going to be placed here. Yes, it is changed now. See, I am maximizing it for you. Are you getting? A signal board of 2 DI and 2 DO that is I 4.0, I 4.1, Q 4.0, Q 4.1. Now they have given this number. You can change this number as well. So click on this, open it. As we have maximized the screen, you need to adjust a bit. See, I address starts by 4, Q address stands by 4. I will change it to, so I will change it to, I think we have used 10. Okay, if you closely observe to this, we have used 10, we have used 11, so I can write it as 1 or 0. So the input has changed to 0. I will also change the output. So what they are telling that this address is already being used, because we have not changed address of digital output, yes, which are present on board. So I will change it to 10. Yes, it has taken 10.0, 10.1. Okay, and it is specifying that it is a 24 volt DC, 0.1 ampere is the current which we will be taking, and it is a signal board. Its number is 1223. Okay, now these are the steps for adding a signal board. Similarly, you can add analog input, analog output, or digital input, digital output individually. Also, similarly, you can change the addresses as per your requirement. Okay, see on this if you closely observe, if you are viewing this project again and again, so you could see that I have given the name of the first digital input to pump start, and the first digital output is blink, the second digital output is pump on. Yes, if you are not the first, if you are the first time viewers, I will just change and show you that this is my first input. Okay, it starts from, its address is 10.0. okay, I will open my OB. Yes, it's at 10.0 and it's pump start. Pump start. And if I go into my output, see pump on and blink. First one is blink and the second one is pump on output, which is available here. Blink on and pump on. Okay, so whatever we do in our PLC logic, the same is being replicated here. Okay, now I will minimize or just zoom out. Okay. So it is now in a normal mode. Okay. Respect. Okay, now we will add the digital input module or analog input module here. Okay, I will show you how to add it again. The procedure is same. Go to analog input. See, there are number of analog inputs available. Whatever you want, you can check it. So I will go. First of all, I will add 8 analog input channel. Now this is the MLB number which is available on your hardware. 6S72314 4HF320XB0. Just drag and drop. The hardware is available. You can name it as well. For example, process section 1. That means this card belongs to process section 1. Okay, so it is available. If I again zoom it for you, you can see. So the addresses are available as IW96, IW98, IW100, 102. Okay, so this is available here. Now what we will do is, I will show you. Now this is an analog input. Okay, we will go, sorry, it is an analog input, and we will go into properties, analog input. See, I will show you the difference between the two analog inputs. First of all, I show this as a separate analog input module, okay, which we have recently added. Now this can be configured as voltage as well as current. So by default it is voltage configured, and the range of voltage is plus minus 10 volt, plus minus 5 volt, plus minus 2.5 volt, whichever is required by you. Then if I want to add is current, I will change it to current. Okay, now for current I have the range as 0 to 20 and 4 to 20. Okay, again I also have the facility of changing the analog input channels. So actually every input is called as a channel. What will happen? Okay, so see, as you have changed channel 0, channel 1 is also changed, yes, to current, but channel 2 and channel 3 will be same. Channel 4 will be unchanged. Now what happens that whenever you are going to change the setting of this analog inputs, they will be changing in a group. 0 1 is a group, 2 3 is a group, 4 5 is a group, and 6 and 7 is one a group. Okay, so this is how it changes. Then again come back to our original CPU. So this is the CPU. Okay, now this CPU, what does the CPU have? As we have already discussed, that this CPU has two analog inputs available with it, but they are pre-configured as voltage. Okay, we'll go into it. AI2, I am into my PLC module right now. PLC 1, CPU 1214C, DC DC DC. AIs, see, this two channels are by default configured as voltage. I don't have the facility of changing it to current, and the voltage range is also from 0 to 10 volts. It is not from minus plus minus 10 volts. Okay, this is a major difference between these two analog inputs. Now we will configure an analog input. How to configure it again? Same procedure. Four. I will add this one. Select. So the number, also see the number, it is SM1231. It is a range of signal modules for AI. SM1232 is a range of, or is a series for analog outputs in Siemens for TI portal. Then see the addresses are being available: QW112, QW114. QW stands for analog output. Again, if I enter into the properties of this, they will be again bundled into a group of four. Two. So the first one is voltage. I will change it to current. I have the option of 0 to 20 and 4 to 20 milliamperes. Yes. So channel 1 is again now see. It has changed. But in the case of analog outputs, they can be changed as per a requirement. See, channel 0 is current, channel this is current. I want this as voltage, I can keep it as voltage. So analog outputs are isolated. First can be voltage current, second can be voltage. But for analog inputs, they are in a group of two. In analog outputs, they are not in a group of two. Okay, this was about analog input, analog output, general analog input, general analog output. Okay, we will now configure here the analog input, which is for RTD. Yes. What's the difference? We will just check it out. See, addressing style will be same. Addressing is not an issue here. The series will change. SM1231A RTD. Now, what changes here? In the measurement type, as there was current and voltage, in this we have thermal resistor 4 wire, we have resistor 4 wire, 3 wire, 2 wire. So they are giving us the measurement types, that which type of resistor you have, because it is a RTD. Then which thermal resistor you are using, PT100, NI100, PT500, NI120. So whatever is the standard you are using, select it. Then based on that, what will be the temperature coefficient, which scale you want. You want Celsius or Fahrenheit? This can be selected and it can be changed. Okay, so if I want it as 4 wire, first one is thermal resistor, second one is resistor. So they are also not in groups. So this was all about analog input, analog output configuration, RTD, and same applies to thermocouple. So in thermocouple you will be having the thermocouple ranges. So we'll just add one, and then we will shift to how to add communication modules. So it is again a thermocouple input. I will directly jump over to the properties of that. Okay, now you will have a thermocouple. They are using K-type thermocouple. So if you want just a voltage, you can change it to voltage. You want deactivated, you can use it. Type K, type B, type R, type J. Celsius or Fahrenheit. Yes, internal reference has to be given or not, or parameter setting. So these are all the options available while you add the modules. Now by how many numbers you can add? You can add up to 9. That means 1 plus 8 modules on the CPU, on the right hand side of the CPU, and on the left hand side you can add only 3. These are the communication modules. Now before entering into this, I will let to explain that what is the need of communication boards. So communication boards are used for communicating this PLC with a third party PLC, communicating this PLC with the third party device. So what do you mean by third party device? Third party device means it is not having this Profinet port. It is having something like RS485, RS232, or it is having a Modbus TCP, or it may be having a Profibus port. Okay, for this purpose we use this. Now just go into catalog, go into communication board, go into point to point, add CB1 for RS485. Now at this moment I am just having RS485. Okay, I will add it to here. So this is a communication board. Now this communication board is something like signal board. It can't be placed here, it can be placed here only. Then I have communication modules as Profibus module CM1242, CM1435. So CM1243, I can add it here. A Profibus port, yes, a 25 point connector is available. Then I want to go for point to point, that is RS232, 485, 422, 485. I will be using this. Now by serial, because sometimes the LED displays and all that are available in serial port, so we can use this one. And then how you can configure this is again going to properties, going to interface. Port will be having this baud rate and all that, and you can change everything. This is how you can add the communication modules. Now this was all about how to create a hardware configuration whichever is required by you. All the modules, how to add and how to rename it, how to change the properties. Thanks for listening.